In this video, I will be testing the interfaces of an operator-controlled desktop application. This application was written in Python and can be run on a desktop or laptop computer with OS X connected to a Zigbee radio device with a USB cable. This application allows a user to issue 4 distinct commands to a microcontroller in a remote location. This video will utilize 2 tests to demonstrate the following properties. The application can run on OS X. The application has a startup time of under 5 seconds. 10 inputs can be transmitted in a given minute. The transmissions can go over a distance of 9 meters without any line-of-sight blockage. The transmissions can go a distance of 1 meter through a standard wood door. And that 4 messages can be transmitted: on, off, increase load, and decrease load. And that these messages are available to operators and can be differentiated from each other on the receiving end. In addition, the transmission rate must be 96 bits per second. This will not be demonstrated in this video as it is guaranteed by the Python code. For the first experiment, I have connected one Zigbee radio to my own laptop via a USB cable and placed it at the end of a 9-meter string. At the other end of the string, there is another Zigbee radio, which is connected to a microcontroller, which is connected to the laptop of one of my teammates. As you can see, the application starts in about 3 seconds and presents 4 commands to a user. Each of these commands are issued at least twice. The process of issuing 10 commands takes under 30 seconds. Now let's look at the receiving end. 4 distinct messages, the letters A, B, C, and D, are identifiable on the computer that receives the message that has been transmitted through the Zigbee radios. Receiving 10 messages takes roughly 20 seconds. Now let's look at our second test. On one side of a closed door, we have a Zigbee radio transmitter connected to a laptop with OS X and placed at the end point of a rope. On the other side of that closed door, we have the Zigbee receiver connected to a second laptop, with the receiver next to a knot that was tied on the 1 meter mark on that same rope. We will now start the application and begin transmissions. Once again, we observe that the application runs on OS X, that it starts in under 5 seconds, this time we see 4, and that 10 transmissions can be sent in under 1 minute. Now let's look at the receiving end. We once again observe that 10 transmissions are received, including 4 distinct transmission messages, A, B, C, and D, and that these 10 transmissions are received in under 1 minute, in this case 21.4 seconds. When testing this application for transmitting messages over 9 unobstructed meters of distance, we needed to record the following properties: that the application could start up in 5 seconds or under, that the application could transmit 10 messages in 60 seconds or under, that 4 distinct messages would be transmitted, and that the application would run on OS X. We saw was that the application started in 3 seconds, that it took 20.4 seconds to transmit 10 messages, that 4 messages were transmitted, and the application did in fact run on OS X. When testing this application's ability to transmit messages through a closed door, we needed to observe the same qualities as before. This time we saw that the application started up in 4 seconds, that it took 21.4 seconds to transmit 10 messages, that 4 distinct messages were transmitted. The application once again ran on OS X. This block has met its past conditions during testing, and its interfaces can be confirmed to be functioning properly.